All right. So as I said in the first video, these examples that I work out for you are going to come directly from the textbook. So they're the same examples in the textbook. That way you can look at their solutions. If you don't like the way that I'm doing it, right, you can look at their solutions. Anyway, so let's do this, right? So if we want to solve this equation, I'm going to try to get it to look like one of those formats that we talked about at the end of the last video, right? In this case, since I'm dealing with a sine function, I'm going to try to get this to look like sine x equals k. Or in this case, sine theta equals something, right? So I'm going to start off by solving for sine theta. So I subtract 1. Maybe I'll use a different color. Okay, so I subtract 1. And then divide by 2. Okay, so now I've got it in that format that I like, sine x equals k. Now I'm going to apply the rule, right? So the rule from that list of facts. So if this is the case, then I know that either theta equals sine inverse of negative 1/2 plus 2n pi, or theta equals pi minus sine inverse of negative 1/2 plus 2n pi. And that's it, right? That's all there is to it. I mean, of course, I expect you to do some simplifying here, right? So I would expect you to say something like, well, first of all, we can figure out what sine inverse of negative 1/2 is. If you don't know it off the top of your head, you could use your calculator, but give me exact answers. So if you're going to use your calculator, make sure that your calculator will give you an exact answer here. In my case, I think we can do this in our heads, right? So to get sine of 1/2, we'd have to be at pi over 6. Since this is sine of negative 1/2, I think we're at negative pi over 6. Okay, so sine inverse of negative 1/2 is negative pi over 6. So one of the solutions, so we can say theta equals negative pi over 6 plus 2n pi, or theta equals pi minus negative pi over 6 plus 2n pi. Pi minus, so this is 6 pi over 6 minus negative pi over 6. So that's 6 pi over 6 plus pi over 6. That's 7 pi over 6 plus 2n pi. Okay, and that's all there is to that. If you wanted to put your answers into a solution set, you would say something like, the solution set is the set of all numbers of the form negative pi over 6 plus 2n pi, or numbers of the form 7 pi over 6 plus 2n pi, where n is an integer. Okay, and that would be your solution set. So that would be one way to write down your solution set. Now, oftentimes, you're not necessarily interested in finding all of the solutions. You only want to know the solutions that live between 0 and 2 pi, or that live between 0 degrees and 360 degrees, or whatever, right? If that were the case on this problem, if we wanted to know, well, which of these solutions, right? This describes infinitely many solutions. Which of them live between 0 and 2 pi? Well, so then what you would do is start taking turns plugging in numbers for n. And then you only keep the ones that live between 0 and 2 pi. So maybe I'll say this. So the solutions that live between 0 and 2 pi are the following. So dealing with this first set, if I plug in 0 for n, I get negative pi over 6, and that's too small. Right? If I plug in 1 for n, then I get, this is 2, that would be 2 pi. 2 pi is the same as 12 pi over 6, right? So I have 12 pi over 6 minus pi over 6, that's 11 pi over 6. Okay, so that's what I get when I plug in 1 for n. If I plug in 2 for n, now I have 4 pi 4 pi minus pi over 6 is going to be way bigger than 2 pi. So at that point, I've gone beyond the interval that I care about, right? So that's all of the solutions that I'm going to get between 0 and 2 pi that are generated by this first rule. Then you do the same thing with the second rule, right? Like over here, if I plug in, let's say if I plugged in -1 for n, I get 7 pi over 6 minus 12 pi over 6. That's going to be -5 pi over 6. That's less than 0. So that's not going to go into my solution set here. If I plug in 0 for n, then I just get 7 pi over 6. That's between 0 and 2 pi. Right? So 7 pi over 6 belongs in that solution set. If I plug in 1 for n, then I'm going to get 2 pi plus 7 pi over 6. That's going to be bigger than 2 pi, so that's too big. Okay? And so that would be it, right? So the solutions that live between 0 and 2 pi are 11 pi over 6 and 7 pi over 6. Okay? So that's that.